My name is John Baier. I am the VP of Product and Solution Strategy in our portfolio group. One of the things that I get to do is work with our Lighthouse customers. So I run our Lighthouse Early Adopter Program, and some of them are here. We get to work on the new technologies, and we're going to talk about two of them here today. Damien Rouge is my colleague. He is a product manager in our enterprise integration group, and you're going to get a sneak peek of our brand new functionality integration with Databricks, so stay tuned. So we're going to talk about two sides of analytics with Connect. One is low code, no code, using our advanced analytics tool. This is offered through our partner, TwinThread. A lot of what I talk about, you can go see and experience in the Product Expo. I encourage you to do that. I'm going to try not to have a bunch of slides and screens that you can't see. I invite you to go down and experience it directly with our experts in the Product Expo. The other piece that we're going to talk about is being able to do analytics on Connect in typical enterprise integration or data frameworks. And we're going to show you Databricks, but it's not limited to just Databricks. So kind of low code, no code for the operations analytic, help yourself. Powerful analytics for writing code in Databricks for the professional data scientist. So I think everybody here gets why customers are spending so much time on analytics. And real-time or time series data is a key enabler for getting the value out of analytics that you're looking for. You want to get more out of existing assets in better productivity out of your assets. A lot of people want to monitor energy or optimize energy. And find that sweet spot between optimizing energy and getting the most production you can. People want to provide a circular loop or closing the loop, as Rob McGreevy talked about this morning. It's not just enough to do the analytic, but we want to bring it back into the control system so that they can be applied automatically and at scale. We want to enable our digital workforce so that they can take advantage of data at scale as well. And this is all around optimizing existing operations, but also getting ready for the next generation, the green fields that you're going to be putting in. When I talk to a lot of customers through our Lighthouse program, one of the biggest things they talk about is, how do I get faster? How do I do projects more quickly and with more reuse? And that's a big part of what we are doing here with our analytics strategy. So just as a grounding, this is all around our Connect platform. You've heard about Connect Data Services, which is really the fundamental time series and context for industrial data. Our Connect Visualization Services for runtime visualization, both for ad hoc visuals as well as full applications like UOC, like you see on the big displays. And then this is really focused on the modeling and analytics part. How do you work within the platform to get more out of your data that you're already collecting, or that you've collected in the past and maybe you haven't really been able to take advantage of? We want you to be able to bring that data to life. So what is AVEVA Advanced Analytics? So AVEVA Advanced Analytics is a full SaaS tool deeply integrated with our Connect platform. So our partner TwinThread integrated this directly with the Connect Data Services and Connect Visualization that you see, that I showed you in the previous slide. It enables you to solve all kinds of different problems. It's a generic tool set that you can use across assets and across processes to optimize, either or both. It does this based on you going through a series of wizards that allow you to set up a machine learning algorithm. And all you really have to do as a control engineer or process engineer is answer some questions around your data, And you'll have a chance to go back, but it will take the simple questions that you answer and try to build a machine learning model for you based on previous data that you have collected. So this is a data-driven approach to looking at your data, finding the patterns, finding the anomalies, and building a model that you can approve and put into runtime. So you start by creating your model. You start getting some feedback about how the model's performing. You put the model into a runtime mode or monitoring mode as new data comes in. It's going to continuously evaluate your model and then alert you for new findings or actions that need to be taken. So the kind of applications you can solve with advanced analytics are pretty broad across the board. In the process optimization, perfect energy is really at the sweet spot of every industry, every application. Really trying to get the most out of your assets while minimizing the use of energy. And that's energy of all types. Everything from steam, electricity, gas, water. This is really a key thing for sustainability for every company out there. Perfect production is really around understanding how to get more out of your production facility. How can you get more out of existing assets? How can you produce more with less waste and more efficiency? Perfect quality is all about really making the right output and making sure that it's right the first time and not having so much variance in what you produce or waste. And we're going to talk a little bit about the Nestle use case at the end of this, but we have several great presentations here at AWC that look at perfect quality and got some really great results. And then finally, perfect batch is similar, but all around batch operations. How do I get the golden batch and start making every batch as good as the golden batch, if those of you are familiar with that terminology? So those are all around process. There's also some great functionality and built-in models for dealing with assets and asset efficiency. Of course, the first one that comes to mind is uptime and optimizing uptime and reliability. So real-time alerts and recommendations to avoid downtime before they happen. Throughput optimization to make sure that your assets are constantly being used, and not only from a downtime perspective, but a usage perspective, right? Make sure that you're scheduling your processes so that they use your assets most efficiently. And then finally, asset reliability and remaining asset life. These are all about the aging your assets and making sure you understand what a proactive maintenance strategy might look like, so that you're not maintaining and going out and doing maintenance runs too often, and that you're doing that based on the data that you're seeing, not just a schedule. So again, 3 big steps that we see for advanced analytics. The first one is creating that model factory. This is, you can pick all those 8 models that I showed you. You can pick one of those that you want to go down. We have wizards that are pre-configured to walk you through the necessary parameters to create that type of model. And you simply go into your Connect Data Services streams or assets with the metadata and pick the data that you want, make it part of the model, and walk it through the wizards, and it'll start to train the model going back as far back as you want. Typically, this is going to be several months or even years of data that you may want to look back in history to look for anomalies and look for patterns. The twin configuration steps are super easy. You don't have to be an expert. It's simply point and click. The other thing that this does is when it's done doing its training, it evaluates several different potential models against, or algorithms, AI algorithms, against the data that it sees. So it'll show you the models or the AI algorithms that it applied, and which one is showing the best results or the most accurate results. And then all you have to really do is follow the recommendations, pick the best model, and off you go. There's great visualization along the way to take you along this path. And that's really where the model behavior analysis comes in. These are pre-configured visualizations. You don't have to create them. You don't need to do anything other than choose the visual that you want to see. Things like the predicted quality value or top model drivers are automatically generated for you and shown you in a nice graphical form. So really, this is kind of telling you this is how your model's working, what you can do to make it better, or maybe it's boy, this looks great. There's only 2 real factors or 3 real factors that are meaningful to my model. You don't need to worry about the rest. The other thing that this does, and we've seen really, really useful out in the field, is shows you ideal running conditions. So this sort of visual that'll show you this is the ideal running condition for certain parameters, where you're at, and what you need to do to adjust it to get more to the ideal. And this was used directly in the Nestle use case to be able to optimize their product quality. So this is really great. No code, not even, don't have to create visual screens to be able to get this input. It's all created automatically in the advanced analytics application. So the other piece, once you put a model into operation or runtime mode, it'll constantly score your model and score your real-time data, new data, against the model. And send you can either configure, or there's some automatically configured alerts and actions that can drive to you via email, via text. And you can get those alerts and take action before you have a problem. So, and that may be adjusting some parameters down on the plant floor. It may be reacting to a pending failure condition that you can do something about and fix before it becomes a failure. The other really interesting thing on closing the loop that I mentioned earlier is advanced analytics will also take actions and anomalies scores and write those values back into Connect. So they can be driven all the way down back into your control system, whether it's back to the operator display or even all the way to a PLC for set point analysis or taking action on the plant floor. So this is the closing the loop that Rob talked about in the keynote. There's obviously some people get concerned about taking something up to the cloud and bringing those kind of data values back down. But let me assure you, this is not trying to be a control system. This is simply providing recommended set points to run your systems more accurately. So this is the picture of really advanced analytics. As I said earlier, it uses data services, both the asset context, the event context, and the streams all natively. It doesn't take a copy. It basically only caches what it needs to be able to provide the analytics. We're working on making it integrate natively with Connect visualization services. So those recommended predicted values and recommended values will show up directly in Connect visualization services. You can also do some pretty simple things with the advanced analytics tool. So beyond building models, there's a great thread engine. This is basically write your own analytics, write your own calculations. And you can write that through a simple editor. That's a simple workflow editor to be able to do that. This is really handy for a lot of people. For those of you who've used PyAF or done calculations in PyAF, this will be a very similar experience, except with a nice graphical editor and in the cloud. So this set of tools, there's no real end to all the things that you can do with this tool set. And all of this is help yourself. You don't have to write code. You don't have to go to your IT for a project. So the next piece, okay, So people say, great, that's nice. But I have a whole set of professional data scientists. I have my own. I want to develop my own algorithms, and I want to use modern enterprise data tools like Databricks or Microsoft Fabric or Snowflake. What can you guys do here? And so this is where we're providing the integration from OT and the industrial data that you get in Connect, and extending the data lake architecture or the lakehouse architecture by providing links to data back into that OT data. So again, what we're trying to avoid is data copies, especially at scale and for large amounts of data. As they say, if the data's in 2 places at once, it's wrong in at least once. Okay, so, and the worst thing you can do with analytics is try to have, if you don't have good data, you're not going to have good analytics. So you have to be able to trust your data. So this is all about data trust. And Damien's going to take you through this. So what we're going to show you today with Databricks, we're also over time going to apply with Snowflake and Fabric and maybe some other end data experiences at the enterprise level. But really what we want to get to is OT data extends the data lake. You use those larger enterprise data platforms for combining data from HR systems, LIMS systems, maintenance systems back with the data that you get from the OT side. So with that, I'm going to have Damien come up and walk you through that integration. Damien?
Thank you so much. The goal of the incoming slides is to focus on the integration within the unified analytics platform, such as Databricks, but not only that one, and to review the end-to-end video that will coming in the next coming slides. It's an end-to-end video that really explaining all the steps that we have to pass through for enabling the data sharing in between the 2 environments. Connect platform bridges the OT and IT gaps by enabling the shared data, across the whole organization. So we may face, or we can face, 3 main user patterns in that use case. Typically, the OT and the IT, right, coming from the organization personals, but that includes also the whole ecosystem. That includes definitely the equipment manufacturers and the analytics providers. The goal remains or stay to make the documented decision on time based on the most accurate and real-time data coming from various data sources. Right. So Connect data virtualization, also called the virtual table capability, ensure the most accurate real-time data will be available on demand, boosting the operational efficiency and also cutting the storage costs, which are a key component of this kind of integration. So by, let's say, avoiding the data replication or data copy, right? Because it's clearly a zero copy concept that we have implemented there. And by enabling the native contextualization, then the end user are really in a position to focus on making the right decision on time instead of managing the data. So providing the larger, I would say, industrial data set to the end user, typically to the data analyst, data scientist, or business intelligence analyst, has always been challenging, right? Because that's a very massive amount of data to transfer and to expose to those, let's say, domain expert. But enabling this kind of architecture requires to have significant effort in the design standpoint, but also in the monitoring, in maintenance, and with a pretty limited scalability at some point, or relative scalability. So Connect here, let's say, enables the integration of internal data sources and external data sources as well. And there are 3 aspects to keep in mind here in terms of values. Is first of all the no data left behind. The system is always taking care of the most accurate data, which is really something fundamental here. And in addition to the world-class scalability, that's typically something which is really linear. If you are extending broadly your infrastructure, the system will sustain the the way that you are growing up at your speed. And the third aspect is the ability and the flexibility of the system for absorbing any new cases coming with a very limited effort. That's really, really important. Before switching to the swapping to the video, it's important to position different technological layers, which are absolutely key in articulating or, let's say, leveraging this integration here. The first one is the Unity Catalog. So Unity Catalog is a unified data governance solution, right, coming from Databricks, definitely. And that's the place where the end user can really manage all the data, typically managing the access, the data access. In addition to, I mean, you can have real-time auditing. You can also track the data lineage across various, let's say, team, cloud team, and sources. So that's a quite important pillar of this integration. And then if you look at, let's say, down, you will see there are what we call the uniform. Uniform is a standard format used for enabling across the platform, typically Databricks, but not only. John mentioned earlier the snowflakes and fabrics. This is the same philosophy for preparing the data to be consumable by those platforms. And uniform is a combination of two things: Delta Lake, which is the left-hand side logo, right, and the iceberg from Apache. This is for structuring the metadata and enabling it across the different platforms. And then we have the Parquet files. Parquet is the way we transform the data and store the data, and all those data lands on the Azure Data Lake storage. So about the point-and-click and the workflow, we'll see during the video how it looks like. So we have Josh. Josh is the data architect. He's responsible for enabling the integration in between Connect Data Services and Databricks, right? Then we have Suzy. Suzy operates mainly in the business intelligence domain. So she's responsible of making some KPIs, some collections of KPIs, implementing them, and then also, maybe I can pause it now here. Same thing, whatever. So yes, and Laurie is a data scientist. She's in charge of implementing an unsupervised anomaly detection model. So both they have some needs of investigating the data from the Connect platform. So that's what they are doing individually here, reviewing the data, checking the different statistics coming from their analysis, and then for Laurie, looking at some data correlation. When Suzy in the business intelligence layer, she's looking at how to implement different KPIs for improving the efficiency of that given spread higher they are, let's say, analyzing right now. So then, for going further, they requested Josh to enable the what we call the virtual table. So Josh starts by reviewing the different data views available within the system. If one matches the need, then he will use that one. He will check the outcomes of or the result of executing this data views. And we'll go also on the API side of things, what we call the API console, checking if the API responds properly as per the request is set up on the get parts. So then Josh goes to the virtual tables part. He will create a new virtual table. He will select the data views that he needs to virtualize, and then he will pass to the workflow for naming the virtual table, then selecting the retrieval modes, and he will go for the time extended window as per the request coming from Suzy and Laurie, right? So he will just select data collection start time and then go to the next part with a scheduler set up on 1 hour. Here, this is the main important things. This is where Josh will enable the relationship with Databricks. So as such, or to do so, he has to go on the Databricks workspace side of things, and he will collect what we say the metastore ID, copy sharing identifier. This metastore ID is required for enabling the relationship from Connect to the Databricks workspace tenant. Right? Then once done, he will save it and then can review on the side sheet. You will see the summary sheet where he can review the configuration on that's given virtual table creation. So again, this is a draft of the future summary sheet, but it gives you an idea. Then I can review also on the Connect side of things the different permissions and privileges assigned to different groups, and can modify it. So then, back to Databricks workspace, then Josh needs to go to see the delta sharing part and find the recently created providers. By clicking on that, he can create a catalog that will create a new entry within the Databricks catalogs, right? And he can also assign the proper privileges for the different user group or users within Databricks. and then makes the catalog, this new entry available as a shared catalog within the Unity catalog of Databricks. Right, so then the job is done here, right? So the data are virtualized and they are ready to be consumed by any Databricks user that got the proper privilege. So then Josh can double check if all the data are, let's say, consumable from Databricks standpoint, right? And you can also execute some SQL statement to review the data consistency if everything is really available as it should. Then we have Suzy. So Suzy is looking about consuming those datasets recently shared by Josh, right? So she will investigate about the different time series available. So there are, in that example, 5 metrics for that given spread higher, right? Including vibration, including inlet temperature and pressure, speed, and so on. So Suzy uses the embedded dashboard component. And now she's looking for going to an external tool. Could be Power BI. In that example, she uses the Tableau desktop. So she downloads the connection files from Databricks that she can load Tableau desktop or even Power BI, same way, right? And she can design different KPIs she wants. And then she's combining all those KPIs into an overall KPIs called the spread higher overall efficiency, operational efficiency, sorry for that. She's managing a dashboard combining the different indicators, KPIs, and then she's publishing that across to share that dashboard across the company on Tableau Cloud, for example. Then we have Laurie coming. So Laurie, remember that Laurie has in mind to design an anomaly detection algorithm. So she starts by creating a notebook, right? And from the notebook, she will go step by step by consuming the different available data that she would like to combine within the model. Then she will pass to what we call the ADA, so the exploratory data analysis, reviewing the different time series, trying to find some correlations in between the time series. So she follows exactly all the steps that are recommended steps when you are making this kind of unsupervised machine learning algorithm. So going to this step, this is the most important ones here. She decided to go to the isolation forest algorithm. There are plenty of different kind of algorithms. Isolation forest is one of the most simple ones for, let's say, making anomaly deviations, and then let's say, applying that over this given model for that given spread higher. At the end of the day, she can, let's say, also review the distribution of the different anomalies across the variables. To complete on that, how to circle back then to the shop floor operators. Typically, by the next step, once the notebook is, let's say, completed, then Laurie has to deploy the model. Deploying the model means there are different approaches. The first one is to make a batch deployment, so regularly the model will be executed and evaluated, right? The second one is, I would say, hosting the model behind the scene of a REST API. That means any front end can consume first the model by asking or by executing the model, getting back the outcomes, and then displaying the outcomes within the given front end. To complete on that, there are also additional, let's say, mechanism for notifying, like through Slack or Teams or some, let's say, instant messaging system, or through, for sure, through emails, and as well, some reports can be also shared with the operator for, let's say, getting the outcome of the machine learning execution and see what would be done for improving the efficiency of the asset. It was a bit fast, sorry for that. Up to you.
Thank you, Damien. We know that was fast on purpose, but I'm super excited about this. I know our friends at Agnico Eagle are. They'll be one of the first ones that test this in our Lighthouse program. So I'm going to do a couple ads here for some other sessions to go see. Both of these companies are presenting tomorrow. First of all is Nestle. We worked with Nestle in Lighthouse to bring forward the perfect quality module from Advanced Analytics. And basically the results, what they were trying to do is get a consistent jar weight and jar fill level for Nesquik products. They have been struggling trying to find an algorithm to predict this properly and provide action to operators to make it perfect, if you will, for a long time, many, many years. Now, this is a plant that's been going since the 1960s. So this is taking existing assets, existing data, and bringing it forward and doing new things with it. And what they achieved was 10% savings on powder in the trial, so raw materials, consistent jar weight in the product, which was causing a lot of consumer complaints, and they reduced waste significantly because they were putting the perfect amount in every time, and they didn't overproduce and didn't underproduce. Please go see that talk tomorrow. It's, I think, at 2:30, if I remember right, or maybe 2 o'clock. Right next to it is Acciona. And Acciona, this is more of a process or asset optimization. This was really being able to do perfect energy, if you will. Being able to run pump at the perfect speed to be able to use the least amount of energy and get the most throughput of their water salination plant. Again, super high value use case with one simple model from Advanced Analytics. And now they're moving on and looking to implement this across their fleet of assets and across multiple plants. So please go see these talks. Super interesting. These were both through our Lighthouse program, but the key here is that you can see how people in the operations side can help themselves through self-service analytics with Advanced Analytics, and people who really want to go into data science and have professional data scientists, we're sharing data in a compelling way with Databricks, Snowflake, and Data Fabric. So with that, I'm going to say questions.